Okay, so today we're going to talk about temperature. Now, before we get into the definition of temperature, one thing we need to understand is you guys have been talking about energy for the last 2 days. So energy, again, is just the cause of something changing, right? And we've been talking about the change in things, really big concepts, objects, and things that you can see physically. But we're also talking about what happens with the energy of things that we can't see. One example of that is the energy of particles in an object. Okay, so temperature really is just a measure of how fast or the kinetic energy, the moving energy of particles in an object. So as a temperature increases, the average speed of particles increase. Okay, so that means that if we go from 80 to 90 degrees, that means that the particles are going to be increasing in their speed, which means the kinetic energy of the system is going to be increasing as well. So again, the temperature unit, the SI unit for temperature is going to be Kelvin or degrees Celsius. Normally Kelvin is for really scientific purposes. It gives you the absolute value of numbers. This is more just day-to-day use. Notice that Fahrenheit is not. The picture here I think is easy to understand. Particles are never still, they're moving, and as they decrease their vibrations, the temperature also decreases. So they go hand in hand. The movement and the temperature go hand in hand. So we can say that the thermal energy, or the sum of the kinetic and potential energy of all the particles in the object. So what I mean by that is there's going to be times where they slow down, there's going to be times when they speed up. The sum of those actions is called thermal energy inside the object. So we can say that as the kinetic energy increases, or the speed of the particles increase, it raises the temperature. Okay, and if that's the case, then if you raise the temperature, that must mean the thermal energy increases as well. So right here you can see that larger kinetic energy means a higher temperature. A lower kinetic energy means lower temperature. Also, we can compare thermal energy and mass. So mass increases, as mass increases, the total kinetic energy increases. Because if particles are moving around and you've got more of them in this, if you've got a box and you got two particles here, and then you start adding more particles together and they're constantly moving around, they're going to be running into each other more. When they run into each other more, their movements create a faster movement, which means their kinetic energy is going to increase. So pretty much we can say that if we increase something's mass, we can increase thermal energy as well. So we've seen the word heat. We talk about heat. We say heat all the time, but we may not actually know the definition. Thermal energy that flows from something at a higher temp to something at a lower temp. Okay, so this transfer of energy from something with a high temperature to a lower temperature. This is a form of energy because, again, we're causing something to change, and we still measure this in joules. So we measure heat in joules as well. And it always flows from something warmer to cooler. Okay, so when we talk about it being real hot outside, so let's say we've got a house, and outside the house it's 90 degrees, and inside the house it's 70 degrees. When somebody opens the door, we're not letting the cool air out to the 90 degrees, we're letting the hot air in to the cooler degrees. Okay, so make sure you understand that. Same thing if I have a refrigerator and I have a freezer. When I open the freezer door, I'm not letting the cold air out, I'm letting the hot air come in. So another form of heat we need to talk about is something called specific heat, which is the amount of heat needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. They just took a sample of 1 gram of something, and they seen what they could do if they could raise it by 1 degree Celsius. Okay, you measure this in this unit. We don't have to worry about that, but just to know that it's there. So as a substance absorbs heat, its temp changes depends on the composition of the substance. This is called the specific heat of the substance. So it varies depending on what it is. If it's iron, if it's water, if it's sand, if it's the trees. And you guys have seen this. So on the beach, for example, you know that if you go on the beach, the sand is always a lot hotter than the water, right? So that must mean, again, it's the amount of heat needed to raise the temp. So sand did not need a lot of heat, right? It only needed, so let's say this is sand, and it needs to fill this box up with energy to raise its degrees up by 1 degree Celsius. Okay, well, it may only need let's say 50 joules, but water needs maybe 2,000 joules in order to increase its temperature by the same amount. So that's why it might be 90 degrees on the sand and only 70 degrees in the water. So the question is, if 1 kilogram of sand takes 6 times less the heat to raise it 1 kilogram 1 degree Celsius than 1 kilogram of water, which has the higher specific heat. So water actually has the higher specific heat because it takes more heat or more energy, because remember this is just energy. It takes more energy to raise the water's degrees by 1. Okay, so which can absorb more heat without changing its temperature? Water. Okay, so it might only change its degrees by 3 or 4 degrees within 2 hours. Okay, once the sun hits. Okay, this is for water. Sand, on the other hand, can change 20 to 30 degrees in 2 hours because it doesn't need as much energy, so it needs less energy to change 1 degree Celsius. This needs a lot of energy to change at 1 degree Celsius. So we talked about specific heat, we talked about heat itself, but there's also ways that we can transfer energy, thermal energy, back and forth. Okay, so there's 3 ways. There's one way, it's called conduction. As you can see here, we're pointing to conduction here, which is just meaning touch. And we've seen this plenty of times when you've had to use an oven mitt, or in this case a glove, to make sure you don't burn yourself. It's because of the transfer of energy from this torch or this prong to your hand. Okay, that's touch. Convection is, for this example, this flow of something hot to something cold. It normally goes up in a cycle, goes up in the air and goes down. You've seen this in a pot, and we'll show some other examples on the stove. So any kind of rising heat flow would be convection. And radiation is anything just flowing outward, so it can be in any direction. Any direction, like a radiator, a heater in your car. Those are some examples. So let's go into those a little more detail. So conduction is the transfer of energy by collisions or touch. Okay, this happens because particles are in constant motion. So your hand is coming into contact with this thing, it burns, right? The particles are moving, and then it touches your hand, and your particles of your hand interact with the particles on the stick. And if these are moving faster than these, you will feel that difference, and it'll burn your skin. Thermal energy is transferred by collisions between molecules with more kinetic energy to molecules with less kinetic energy. So again, this one has more, this one has less. So when you will feel the difference when it touches your hand. Heat is transferred by collisions, not by movement. So again, heat moves faster by conduction in solids and liquids than in gases. Why? Gases are more spread out, so the collisions are less frequent. So what that means is you'll feel something more in a solid and liquid than you would a gas. Okay, and so the best conductors are metals because the electrons are not bonded to the atoms, so they move more freely. So you will feel the touch, or you feel the difference in those more so than some wood or something like that. Okay. The next type of movement of thermal energy is convection. So this is the transfer of thermal energy in a fluid, so which can be a gas or a liquid, make sure you understand that, those two things, by movement of warmer and cooler fluid from place to place. So it uses convection currents to transfer energy from warm to cool. So we've seen this in the air, in the weather system, so it's going from a high system to a low system. We also see it right here in this picture of a stove. So it's going to make this warm water go up to the top where the cool water is, moving the cool water down back to where it creates this cycle. Okay, so it still uses collisions to transfer as well, but it's a movement. It's not necessarily just a transfer. It's a cyclical movement. Okay, so as a fluid increases its temp, it expands and it decreases, and its density decreases. And if you were to ask why, it's because the particles have more kinetic energy, so they move faster, so they spread out more. They're not condensed. Okay. And then the last thing we're talking about is radiation. So this is the transfer of energy by electromagnetic waves. Okay, this is a special type. Waves can travel through space, and even though there is no matter, thus radiation is the only form of energy transfer in space. So what that means is the sun is sending out radiation, okay, these electromagnetic waves, and we feel that, and see how it goes in any direction. Okay, the same thing here. So this flame, for example, it can go in any direction. It's not quarantined by just one motion. Now, if your hand is sitting right over the pot, just like this pot is, you will turn your radiation energy into thermal, I guess, convection. So you'll move these warm particles up, and then the cool particles will come down and create this cycle. And then also your hand will feel it because it's going through conduction. So here is radiation, this is convection, and this is conduction. So radiation can be absorbed, it can be reflected, it can be transmitted through an object. So this depends on the material of the object. Light colors are going to be reflecting more, so they'll make them bounce off, whereas dark colors are going to absorb more. Okay, so that's why it's always better to wear light colored stuff out in the sun than dark, because dark will absorb the radiation, the energy, and you'll feel hotter than you would if you wore light colored. And so the last thing is, make sure you understand that radiation can be transmitted through anything, not just solids or liquids, but also gases. And the last thing we're going to talk about is insulators, a material in which heat flows slowly. Good conductors equals bad insulators. So metals, they don't make for good insulation because they move electrons very fast, or they move energy very fast. You don't want that whenever you're trying to make heat flow slowly. Okay, metals, they make heat move fast. You want things to move slow for insulators. So good things that we could say would be insulators are wood, plastic, fiberglass, air, and gases are usually the best insulators. Okay, so here's some different examples that you see. Right, and that's why the gas in our atmosphere helps us to stay insulated, so we don't take everything from the sun just as it's coming in. Right, it helps absorb and slows down that heat flow. Okay, so that's all for today. Make sure you got all your notes down. Thank you.